Welcome back to the SQL Injection training series on the Web Security channel. In this tutorial, we continue exploring union-based SQL injection techniques. This PortSwigger lab focuses on an important concept, retrieving multiple values from a database even when the vulnerable query returns only a single column. By the end of this video, you will understand why this limitation exists and how attackers combine multiple pieces of data into a single column to work around it. The link to the lab is available in the video description. Before we begin, a brief reminder on ethics. This content is provided strictly for educational purposes and authorized security testing only. Do not attempt to use these techniques on systems without explicit permission. In this lab, the SQL injection vulnerability is located in the product category filter. Because the results of the database query are reflected directly in the application's response, we can use a union-based SQL injection attack to retrieve data from other tables. The database contains a separate table called users, which stores usernames and passwords. Our objective is to extract this information using a union attack and then use the recovered credentials to log in as the administrator and complete the lab. To complete this lab, we follow 4 key steps. First, we determine the number of columns returned by the original SQL query. Next, we identify which of those columns can display text-based data in the application's response. Once that is confirmed, we use a union-based technique to retrieve data from another table, specifically the user's table. Finally, because only one column is displayed, we combine multiple values into a single column so they can be returned together in the response. Let's take these steps and see how they work in the live lab. So let's get started with testing. I'll be doing this in Burp Suite, but you can perform the same steps directly in the browser as I showed in the previous video. I'll leave a link to that video in the description. First, I'll enable interception and click on a product category. I'll then send the request to repeater and disable interception. From the lab description, we know that the vulnerability should be in the product category filter, so let's verify that. As in the previous labs, we begin by checking the baseline. The baseline is a normal, unmodified request. Next, I add a single quote. Notice that the application's behavior changes. This indicates a potential injection point. Now I add an SQL comment. At this stage, SQL injection is confirmed. The first step is to determine how many columns the original query returns. In this video, I'll use the order by method, although union-based techniques can also be used. I've covered both approaches in earlier videos on the channel. I'll start by adding the payload single quote plus order plus by plus 1 dash dash and send the request. The response code is 200, which means the query is still valid. I'll now change the payload to single quote order by 2 dash dash and send it again. The response code is still 200. Next, I replace the number with 3 and send the request. This time, I get a 500 response and an internal server error. This tells us that the query returns 2 columns, since order by 2 was the last value that produced a successful response. Now we move on to the second step, identifying which of the returned columns can accept text data. I test each column individually by inserting a text value into one column at a time. If the response is a 500 internal server error, it indicates a data type mismatch. If the application returns a 200 OK response, the data type is compatible and the column accepts text. In this case, the second column returns a successful response, so this is the column we can use to extract text-based data. Now we can begin extracting data from another table. I'll modify the payload to retrieve usernames from the user's table and send the request. Let's switch to the Response tab and look through the output. Here we can clearly see several usernames, including administrator, as well as other users like Carlos and Wiener. Next, we need to extract passwords. I'll modify the previous payload by replacing the username column with the password column and send the request again. Looking at the response, we now see the passwords corresponding to each user. The first, password for the administrator account. At this point, I want to show you how to retrieve both the username and password in a single request by combining values into one column. To do this, we need a SQL injection cheat sheet. You'll find a link to it in the video description. This cheat sheet includes syntax examples for different database types. This is what we need in order to combine two values into one. Because concatenation syntax varies depending on the database, we first need to determine which database the application is using. To do that, we test database-specific syntax from the cheat sheet. We're not guessing, we're observing how the application responds. In this video, we'll start with Microsoft and work our way down the list. In the next video, I'll show you how to identify Oracle specifically. Now I do a quick swap. Instead of selecting password from users, I replace that part with edit version. If the application responds successfully and returns version data, we know we've identified the correct database. We receive a 200 response, so let's examine the page. Scrolling through the response, we can see a string that wasn't present before. This includes the database name and version. Now that we know the database type, we can return to the cheat sheet and select the appropriate string concatenation syntax for our database. At the top of the page, we see the string concatenation syntax for different database types, which shows how to combine multiple values into a single string. Here is the syntax our database uses. I'll update the payload to concatenate the username and password values into a single column and send the request. Let's examine the response. We can now see the administrator's username and password displayed together. To make the output more readable, I'll add the tilde character in quotes between the two values, along with another concatenation operator, and submit the request again. Now the username and password are clearly separated. I'll copy the administrator password and attempt to log in. And as you can see, the login is successful. The lab is solved. In this lab, you learned how to verify whether an application supports union-based SQL injection. You saw how to determine the correct number of columns returned by a query and how to identify which column is actually displayed in the application's response. You also learned why it is sometimes necessary to combine multiple values into a single returned column and how this technique helps bypass structural limitations in vulnerable SQL queries. These concepts are fundamental to understanding union-based SQL injection. In the next video, we'll build on this knowledge and explore more advanced union-based data extraction techniques. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more beginner-friendly content on cybersecurity and ethical hacking. And don't forget to check the video description for all the links I mentioned. If you have any questions or suggestions, please write them in the comments. See you in the next one.